of Arts and Creative Technologies, Sam Johnson, the head Center of Intelligence of Things, in person of Professor Celestine Wendy. Our guest speaker for today, Dr. Vishnu Pendyala, distinguished professors and colleagues, MIBU students, ladies and gentlemen. Today, you are welcome to the 7th session of the November to Remember series of talks for this year, 2025. This inspiring program is presented by the Center of Intelligence of Things and the School of Creative Technologies at the University of Greater Manchester. Our theme for this year, November to Remember, is Powering Possibilities, Technology, Trade, and the Future of Human Development. This session brings together global leaders, innovators, and thinkers to explore how emerging technologies are reshaping our world. And throughout this month, we have been engaging with diverse perspectives on artificial intelligence, trade policy, creative technology, mobile communication, cybersecurity, and also entrepreneurship. All of these sessions are aimed at bridging the gap between industry and the academia. Now, each session in this series has offered not just thought-provoking discussion, but also real-world case studies and practical insight into the skills that will define the next decade of innovation and inclusive growth. So we want to especially thank you for joining tonight's session. And as you know, we've started since last Monday in this year's November to Remember. And we have had great speakers ranging from academia, people in academia, and also professionals of different sorts. Some of the great speakers we have had, at least we have had 7 of them. Today is going to be the 8th. So we have had persons like the IEEE president and CEO San Diego, from San Diego in California, in person of Kathleen Clara, who spoke about IEEE and volunteerism, empowering students for career breakthroughs. We have also had the privilege of listening to Tony Hines, who gave a special talk on supply chain strategies, demand-driven and customer-focused. The 3rd day, which was last Wednesday, we had the privilege of hosting Professor Jacqueline Jog, who spoke extensively on AI and educational opportunity. And the same day, because it was a kind of double portion that day, we were privileged to listen to the DG of the WTO, World Trade Organization, in person of Dr. Ngozi Okonjo-Iweala, who spoke extensively on AI and the future of global trade, the opportunities that are there, the risk involved, and also the multilateral pathway. The Thursday last week, we were privileged to have the person of Dr. Vora Griza, who spoke on AI innovations in businesses. And then Friday, we had Dr. Milos Tesalonivic, who gave the special talk on mobile communication, importance of standard 6G network. And just yesterday, we were privileged to have our assistant teaching professor from the University of Greater Manchester Business School, in person of Noron Nahar, who gave that special, very special talk on the human AI nexus, how we nurture adaptability of the future with technology-enhanced learning. And today is going to be another very special day, because we are having an AI expert with us who will be giving us special talk on AI. I will not announce the title now. You might have seen it there, but I will allow him to specially give us the title, and then we dive deep into the real talk so that we can actually immerse ourselves in everything it's going to give us and then benefit maximally. Briefly after now, I will be introducing our ambassador for the day in person of Miriam Agbalaya, who will then introduce our guest speaker for today. So afterward, our guest speaker will have time to speak to us, and then we have 15 minutes of question and answer. So I want to implore everyone, just get ready. As he's dishing out the special speech, make sure you take notes, and then if you have any question, pen it down. By the time we have the privilege of asking our question, then you can then voice out, because you'll be allowed to unmute and then answer, ask your question, which our speaker will provide answers to. Distinguished ladies and gentlemen, permit me to introduce Miriam Agbalaya, who is our special ambassador for today. Miriam, you're welcome. You can unmute yourself, please.
Thank you so much, Dr. Antonio Ojo, for the warm welcome. Good evening, ladies and gentlemen. I am Miriam Agbalaya. It is my honor to introduce our speaker for today. But before I do that, I would like to say a big thank you to the head of school, Sam Johnson, the head of Center of Intelligence of Teens, Professor Celestine Wendy, our distinguished professors and lecturers, and my fellow students. Dr. Vishnu Pendyala is a faculty member in Applied Data Science and a university senator at San Jose State University, United States. He currently serves as chair of the IEEE Computer and Computational Intelligence Societies, Santa Clara Valley chapters, Area 4 coordinator for IEEE Region 6, and is recognized as a distinguished contributor of the IEEE Computer Society. Dr. Pendyala has also taught at Yongpu National University, South Korea, which is ranked among the top global universities. As a former ACM distinguished speaker, researcher, and industry expert, he has delivered nearly 100 talks and tutorials at leading conferences and forums, including IEEE Global Humanitarian Technology Conference, IEEE Advanced Networks and Telecommunication Systems, International Anti-Corruption Conference, International Crisis Management Conference, IUCEE, ACM India Codes Command, and others. His presentations have reached audiences at prestigious venues such as Stanford University, Google, University of Wisconsin-Madison, University of Hawaii, Computer History Museum, and institutions across India and South America. Several of these talks are available on YouTube and IEEE.tv. As a senior member of both IEEE and ACM, Dr. Pendyala brings over 2 decades of Silicon Valley software industry experience. 1 minute, please. His book, Veracity of Big Data, is available in major libraries, including MIT, Stanford, CMU, and the US Congress. He has also edited 2 well-received books on machine learning and software development, which are included in the Library of Congress and other leading repositories. Dr. Pendyala has contributed significantly to academic development programs, including teaching a Gyan-sponsored course for computer science faculty across India in 2017, and delivering a keynote for an AICTE-sponsored program in 2022. In 2023, he served on the US National Science Foundation Proposal Review Panel. His early achievements include winning the Ramanujan Memorial Gold Medal at the State Math Olympiad. He has also played an active role in the Computer Society of India, serving as program secretary for its annual national convention. Distinguished ladies and gentlemen, join me to welcome our distinguished speaker for this evening, Dr. Vishnu Pendyala. Welcome, sir. and you have the floor.
Thank you, Mariam. That was one of the best visual introductions that I've ever had. Great visuals.
Thank you, sir.
So I'll share my screen. Start to... Okay. So you're able to see my screen, I hope.
Yes, please.
Yeah. So today we are here to talk about the AI or die paradigm that's gaining popularity. The next generation of artificial intelligence is evolving from generating incredible content into enabling entirely autonomous physical AI systems. So the rise of artificial intelligence and autonomous systems brings in a new era of innovation. So in this talk, we'll see what the AI or die race is all about. So the agenda for today is something like this. We'll look at the AI or die race. And then we'll look at what is enabling this race and why AI is becoming so important. And then we'll discuss some present and potential use cases and conclude with some future trends. So I'm a great fan of quotations. So here's one. Any sufficiently advanced technology is indistinguishable from magic. This is from the science fiction writer Arthur C. Clarke. In his book, Profiles of the Future, an inquiry into the limits of the possible, he made this statement. So technology, when it reaches a high level of sophistication, can appear to be magical to those who don't understand the underlying principles. So artificial intelligence is that magic today. AI is pervading everywhere, and the phrase AI or die is a new mantra. So you can see these headlines from various news channels. Samsung needs to do or die mindset to survive AI challenges. Shopify says no new hires until AI can't do the job. AI or dies. Microsoft and investors warn startups must adapt. Pivot or die. Why adaptability is the key to survival in the age of AI. So on and so forth. There are many such news headlines. So AI or die has become the trend these days. So if you look at this plot by METR, Model Evaluation and Threat Research, it's a reputed company, a reputed nonprofit. I think Yoshua Bengio, who is a well-renowned name in artificial intelligence, is an advisor. So they came up with this study, and they found out that the length of tasks artificial intelligence systems can do is doubling every 7 months. In fact, some informally say that they are doubling in their abilities every 4 months, and I think the pace is even faster. So that is the progress, that is the incredible progress that artificial intelligence is making today. So there's a lot of hope. In a recent release event, Elon Musk said that his Gen AI tool Grok is equivalent of PhDs in many disciplines. He also acknowledged that it may be another year or two before they start investing and making discoveries. But he may not have known at that time that a company called Sakana.ai already started on the path of innovation. So of course, there's a lot of hype around it. So there is talk of hope and there's talk of hype as well. But let us talk about the hope first. So this year's ICLR is one of the top 3 conferences in artificial intelligence in the world, and they did an experiment. So this is the message that they sent to the reviewers of the conference. As part of a small experiment that we believe aligns with the theme of our workshop, and of course with the approvals, we have included 3 AI-generated papers out of a total of 43 submissions. As a result, it is possible, though unlikely, that you may be assigned an AI-generated paper to review. If you prefer not to review AI-generated papers and all that legal parlance, so the first ICLR accepted paper written entirely by generative AI tools was produced by Sakana AI's AI Scientist version 2. So this system created a full scientific manuscript for an ICLR workshop without any human involvement. Just a basic prompt was sufficient for the system to cover all the aspects from the hypothesis, experimental design, code, data analysis, to the writing and formatting of the paper. So that's the interesting thing. It was, of course, it was submitted to a workshop focused on, it's not the main conference. The workshop is focused on the limitations and challenges of deep learning. And all this is by just connecting the dots. So these are the 3 papers which were written by artificial intelligence and which were submitted as papers. So the reviewers, as you can see, the first paper, compositional regularization, unexpected obstacles in enhancing neural network generalization, received scores of 6, 7, and 6 in different review rounds, indicating a quality on par with many human authored papers. So a rating of 6 means it's marginally above acceptance threshold, and a rating of 7 means it's a good paper and we must accept it. So of course, this specific paper was withdrawn post-review, but its acceptance marks a notable milestone for generative AI in scientific publication, for publishing. So this is a great example of autonomous agentic AI in action. So the other 2 papers, the second paper received scores of 3, 7, and 4. At least one reviewer has given a score of 7. That means to accept the paper. The third paper did not score all that well. So this is really history made, I think. So obviously there is a race to give autonomy to AI. We have heard of companies poaching other companies' employees with multi-million-dollar deals in the recent times. So according to this Facebook post, if the rumor is true, Meta is assembling one of the most elite and expensive AI brain trusts in the history. Look at the bottom line. So they're planning to pay a compensation of $10 million to $100 million US dollars a year each. So there is a race towards artificial superintelligence. ASI, as it is called, is the hypothetical next level of AGI. AGI, I'm sure you all know, artificial general intelligence. So ASI will be smarter than all humans combined. So if AGI is a genius level human, ASI is like a godlike intellect that could outthink us in every domain, from science to art to ethics, everywhere. So this post is from July 20th of this year. So the the Facebook user even posted a lot of gory details about the people being hired. So that leads to a lot of credibility in the news. So that is the kind of race that we are talking about, or we are in. So that is the overview of the race. Now let us talk about the enabling concept. So previously, to create a machine learning model for a specific task, we need, not just previously, even now, for a specific task, we needed a lot of data, usually labeled, which is hard to get. Getting labeled data is quite an expensive proposition. So now we get tons of pre-trained models on Hugging Face. Hugging Face is increasingly becoming like the GitHub for models. So we can now download one of these generalized models to classify data with unlimited labeled examples. So on this slide, you can see KW in short support set. So KW refers to the number of classes involved in the learning task. In this case, there are 4 classes: squirrels, rabbits, hamsters, and otters. So the 4-way task means that the model is trained to classify data into 4 different classes. And in short means it refers to the number of labeled examples provided for each class during training. So in fact, 0 shot is also quite common. 0 shot, 1 shot is also quite common. So in this case, for each class, there were 2 examples provided. And support set means a small data set containing n examples for each of the K classes used to teach the model. So here we just use eight samples to teach the model. So that is really path breaking. So there's no need for huge data sets. So this is the Hugging Face portal. It's almost becoming the GitHub for models. On the date when I looked up, there are like 1.6 million models which were uploaded, and these can be easily downloaded as well. So that is really very promising. So in context learning is closely related to few shot learning that we just talked. So it's a technique where large language models adapt to new tasks by using examples provided directly within the input prompt, like we talked earlier, right? So this happens without updating their internal parameters or undergoing any additional training. So typically we would fine tune, but instead of fine tuning, the model leverages its pre-trained knowledge and the context of the prompt to understand and perform the task at hand. So in this OpenAI paper, this is a paper from OpenAI, the company which gave us ChatGPT. So the authors demonstrated that large-scale language models like GPT-3 can perform well on a wide range of natural language tasks with only a few examples provided in the context. So there is no need for any specific fine-tuning or gradient updates. So the model does not store or permanently learn from these examples. Its parameters remain unchanged, and the learning is transient, occurring only during inference. So that is the promise. And the authors, so these are some of the findings. So in-context learning is the general capability of large language models to adapt using prompt context. And the authors claim that the effectiveness of few-shot learning is primarily due to the model's exposure to a broad distribution of tasks during pre-training, allowing rapid adaptation to new tasks. Okay. So the performance is pretty competitive with fine-tuned models. That means they are able to, even with few-shot learning, we are able to achieve the performance of fine-tuned models pretty much on some of the tasks. But the performance is not all that good for others and is sensitive to prompt design and model scale. So that is a caveat. So it is quite sensitive to prompt and the examples that you provide. So the performance also is highly sensitive to quality and order of the provided samples. So, so those are the findings from the paper. So as you can see, it is very closely related to few-shot learning. Few-shot learning is a subset of in-context learning, specifically using a few examples to guide the model. So, and quite related to the in-context learning is the concept of compositional generality. So foundation models generalize to novel combinations of learned concepts or features. Compositionality in language and vision requires the model to generalize from familiar concepts to unfamiliar compositions. So that is the idea. So this is particularly important in tasks where new unseen combinations of objects, actions, or attributes must be understood and reasoned about. So training models on multiple tasks or domains encourages the model to learn more generalizable representations. For instance, let us look at this. So it basically, the idea is to leverage few shot and zero shot approaches where models can generalize from a few examples to unseen compositions. So for instance, it enables compositional generality enables autonomous vehicle to compose its understanding to handle unseen combinations of contexts. So the unseen context could arise in a construction zone, for instance, or when a pedestrian is wearing something unusual, like a large oversized costume, or holding a large object like an umbrella or a shopping bag and things like that. So the models in the autonomous vehicle, self-driving car would not have been trained on these kind of data, but the vehicle needs to compose the knowledge of individual objects and behaviors into a new correct action, despite not having seen this exact combination in training. So the models in the autonomous vehicle comprehend novel combinations of road elements, obstacles, signals, and all other such unseen stuff, so that it can react, the autonomous vehicle can react appropriately, ensuring that the vehicle operates safely and efficiently even in unfamiliar situations. So all that is possible because of compositional generality. So the other enabling feature of the AI models is the expanding context window. So think of the context window of a large language model as the amount of text typically measured in tokens, which is roughly correspond to a partial word or a word that the model can think about or remember at any given moment. So a bigger context window means an AI model can handle longer inputs and include more information in each output. So all this is made possible by efficient attention mechanisms and improved positional encodings. So for instance, Llama 4 Scout has 10, the context window is 10 million tokens. OpenAI GPT, ChatGPT 4.1, I think its context window is 1 million tokens. Claude Sonnet also, the context size is 1 million tokens. So that enables, so with large context windows, models can handle super long documents, like the entire textbook in this case, right? Somewhere, full book summarization, right? The entire textbook can be in the context window, combine information from different sources and tackle complex tasks like analyzing code bases, large code bases, right? Large scale code base comprehension, or processing legal documents without forgetting anything from earlier on. So this makes it easier to avoid breaking up the text into chunks. So in a technique called retrieval augmented generation, the text is broken down into chunks, and the relevant chunk is extracted based on the search of the prompt. But all that is not needed in most of the cases. So this gives us a lot more consistent and context-aware responses, particularly when we are chatting back and forth or need to remember what was said before. But of course, there's a caveat, just a heads up. Very large context windows can slow things down. They are more costly to run, and sometimes they can make the model less efficient when it gets too long. But by mixing large context windows with techniques like retrieval augmented generation that we just talked, models can access info that's not right there in their immediate context windows. That means they can go beyond the context window by using retrieval augmented generation. So that is also contributing to the growth of AI. So complex multimodal tasks, real-time analysis, um, uh, and large context tasks. All this is made possible because of the expanding context windows. And of course, no talk on AI into 2025 is complete without talking about agentic AI. So LLM agents are increasingly becoming popular. They are smart systems powered by large language models, or the foundation models as they are called. So they are built to think, learn, and use tools. So that's what differentiates, using external tools to tackle tough tasks even when the environment is constantly changing. And these agents work on their own. They are pretty much autonomous. They adjust to new situations and combine specialized knowledge with context to get things done. Each part of the agent has a specific job. So for instance, the reasoning component helps with making logical decisions. The, the memory component allows them to store and recall important information. And of course, they interact with external tools. So tools let them interact with outside systems and surroundings. So together, these abilities enable agentic AI to adapt, think critically, and adjust their actions to meet challenging goals. So that is probably the reason why they are perfect for handling advanced and dynamic tasks. So then there is this cognitive skills module. It's like a toolkit. So it gives the agent specialized models designed for specific tasks, right? So that is the cognitive skills module. And general purpose large language models uh, typically are not, even when they are fine-tuned, they are not as precise as we want or specialized enough for complex niche kind of tasks. So the cognitive skills modules steps in to fill that gap by providing tailored skills for particular applications. So it makes the agent more capable and flexible. So with these specialized abilities, the agent can handle tasks that require a high level of deep domain knowledge. So it's all about equipping the agent with the right tools for the job. For example, guardrail classifiers in responsible AI to deal with toxicity or misinformation detection are an example of agentic AI, the best use of agentic AI. So those are some of the enabling concepts that are driving the adoption of AI. And now let us talk about the use cases. So use cases are important. So one really compelling use case is in the healthcare domain. So this table represents the breadth of diseases discussed in the paper as detectable or predictable using modern VLMs and the AI-based retinal image analysis. VLM stand for vision language models, just like large language models. Vision and language are combined together to do predictions and classifications, answer questions, and things like that. So VLMs and AI-enhanced retinal imaging can non-invasively detect not only a wide spectrum of chronic systemic diseases, but also key ocular pathologies using the eye images, right? So this review, the paper listed here is a review, a survey paper. It highlights both the potential for early screening and risk stratification. It also talks about the current limitations in the accuracy of diagnosis by general purpose vision language models. So this paper underscores the importance of domain-specific models and continued clinician involvement. So these models are specific to the eye images. So if you see, surprisingly, the eye images are able to detect cardiovascular diseases, the eye images, right? And cerebrovascular diseases like stroke and white matter lesions, retinal age. So basically, the retinal age gap is predicting the stroke risk. So all this would not have been possible with human eye. It is because we are employing these vision language models that we are able to get these tremendous insights. Ordinarily, doctors would not have made out from the images that, for instance, there's a neurodegenerative disease like Alzheimer's disease, but the vision language models are able to do it. So that is the promise of AI. So there are many such diseases. So foundation models and specialized vision language models. One example is Retina VLM. They're emerging to address disease-specific tasks, and they outperform the generalist models in standardized disease staging and diagnostic reporting. So that is the power of vision language models in the area of healthcare. There's just an instance of what vision language models can do. So digital twins are becoming very popular these days thanks to the large language models. So in my university, I recently organized, it concluded last Friday actually. So I recently organized a workshop on integrating large language models into writing curriculum. So it was a faculty development workshop. So I, as part of the workshop, I provided instructions to the participants to create their own digital twin that will write like them in the future sessions, emulating their personal writing style and thought process. So, in fact, I plan to introduce this as an optional exercise for the students in my machine learning course from next semester, because the machine learning course that I teach also serves as a graduate writing course in our master's program. So I'm planning to ask the students to create their own digital twin, like I did here. I can show this digital twin that I created multiple digital twins, which can do a number of tasks like me. So this is a digital twin that I created for something, and then I created PSV are my initials. Vishnu, Srinivas, Pendyala are my initial, my name. So most of the stuff that I do have these initials PSV. So I created a digital twin which works like a writing bot, imitating my style and things like that. So you can have multiple digital twins for various activities. So that is the promise of digital twins at a very high level. at a superficial, probably at a superficial level, but the more promising application of digital twins is in precision medicine. So digital twins help in risk assessment, early diagnosis, and response prediction in treatments. For instance, my medical provider created my digital twin. So a couple of variables constantly monitor my health parameters. So real-time patient data from the variables and health records update the digital twin, allowing for adaptive treatment and early intervention if complications are detected. So I can show you my what is being collected from my variables. For instance, it collected my sleep score, last night's sleep score. Of course, it's not very accurate. I slept for much less than that, but and then the body battery, then heart rate, resting, intensity minutes, and all this stuff. But there is a caveat, right? The caveat is that the data is very confidential. Typically, you would want to keep your data as confidential as possible. So data privacy is a key ethical issue. Also, the validation, the interoperability. So all these are hurdles to the adaptation. So like I mentioned, digital twins are virtual replicas of patient. So they integrate genetic, physiological, and real-world health data to simulate individuals' biological profiles and health trajectories. So when I started on this program, they did a lot of work on my blood. They tested a lot of things to determine the model for me. So the multimodal data from genomics, medical images, variables are converted into a dynamic real-time model for each patient. The models are used to predict disease progression, simulate response to therapies, and optimize personalized care. Of course, this is opt-in. So I requested this, so they did not impose it on me. I requested this. So I pretty much signed up for the risk of data privacy and other validation issues and interoperability. So the great thing about digital twins is that they accelerate drug discovery and reduce trial costs by modeling patient cohorts and simulating drug responses virtually, enabling more precise candidate selection. So they are very useful in drug discovery. So immune digital twin is shown on this slide or illustrated in this slide, is a personalized computational model of a person's immune system. So the model integrates multi-scale biological data to create a digital representation that can be used for personalized healthcare. So data is gathered from various levels. Like I mentioned, my blood was tested for various things, examined for various things. So body level, organ level, tissue level, cellular level, and at the DNA level as well, molecular level. So all the data is then used to create this model. So the goal is to predict the course of the disease, of a disease. Suppose there is a disease, then the course of a disease and the effectiveness of individualized treatments without risk to the patient. So these are some of the real use cases of digital twins for health. Of course, I gave my own example, but Dassault Systems Living Heart project is one another example. It's in fact a prominent example. So it provides a virtual heart model, which is used to test medical devices and optimize treatments for cardiovascular diseases. So digital twins have enabled personalized cancer treatment also by simulating individual patients' responses to a variety of therapies. So this helps oncologists select the most effective treatment pathway while minimizing side effects. So in terms of diabetes, a randomized trial using digital twins for lifestyle and medication guidance found 71% of type 2 diabetes patients reached an HA1C. HA1C is the measure for the blood sugar in the last 3 months. It's an average kind of. And it should be below 6.5 for diabetics. And it was below 6.5 in 1 year for 71% of these diabetic patients. Typically, the standard, if with standard care, the percentage is 2.4%. Compare that to 71% using a digital twin. So that is the power of digital twins for precision medicine. Another example is Johnson & Johnson used digital twins to reduce the size of Alzheimer's um, control arms. There is this concept of control arm, right? Control arm is a group of patients in a clinical trial. So these patients receive, so they are under study basically. The population that is under study is called a control arm. So they use digital twins to reduce the size of this control arm by up to 33%. So that is also indicates the power of precision medicine, digital twins for precision medicine. All that is powered by artificial intelligence. Now, the other promising area is embodied and physical AI. Embodied AI is mainly about AI that's built into physical systems, allowing you to sense, interact, and change its physical actions. Whereas physical AI is a much bigger idea. So it mixes embodied AI with complete independence and smarts. So it can handle everything in a physical setting. So they are quite similar. Both embodied AI and physical AI are quite similar, but physical AI really focuses on the whole system. And being autonomous, it's much more than just embodied AI. So the effects of embodied and physical AI depend on what industry you are in. Embodied AI lets you interact directly with the physical world and adapt, while physical AI gives you more freedom and smarts to run things. So embodied AI and physical AI are increasingly used in many verticals like logistics, healthcare, automotive, extended reality, and so on. So robots optimize routes, handle packages, navigate warehouses, and surgical robots assist in precise operations. Rehabilitation robots provide feedback-driven support, so on and so forth for healthcare. And self-driving cars, we already know, use a lot of embodied AI. Extended reality is another promising area. So a little more detail about the AI-powered robotic surgery. So AI enables precise, minimally invasive surgical procedures. The surgeon maintains control, of course, because we want I'll be talking about the human in the loop. So I think I'm running out of time. So the advantage of AI-powered robotic, many advantages, but one of the advantages is that the surgeon can do this surgery from thousands of miles away using robotic arms. So there are multiple precision robotic arms performing the surgical procedure, each with specialized surgical tool. So that way you can avoid surgeon hand tremors and enable extremely delicate procedures. They can maintain consistent pressure and movement patterns that would be difficult for humans alone. So of course, so the good thing is a person in, say, Asia can get the surgery done by a specialist sitting in United States. The United States surgeon need not travel to, say, India or China to do the operation, to do the surgery. So that is the advantage. So there are many other areas of embodied and physical AI. For instance, drones. AI enables drones to adapt to changing conditions in real time. So that way they can make decisions without human intervention. So this includes adjusting flight paths, changing other actions, and this is particularly important for smart agriculture, right? So they can modify the treatment plans based on new data for the plants. So that is so in this article I explored it's an op-ed actually. So in this op-ed I explored how drones can help the police to ensure safety. So it attracted a lot of discussion online. So people were concerned about privacy and all other issues, and they debated whether it should be ethical to use these kind of things. Of course, there are challenges, but there is a promise also. That's what I mean to say. So for the last few semesters, probably for the last 3 years, I believe, I've been asking my students to program in natural language, right? Like in English. So pandas.ai, I give a homework using for the students to use pandas.ai. So natural language with generative AI tools is really creating a paradigm shift. So this is making programming faster, more accessible, and more reliable through intuitive interactions in everyday language. So I'll not go into the details. So I talked about a lot of, I'll probably also skip a few slides. I talked about a lot of other ways in which artificial intelligence can improve our lives in this opinion piece that I authored last year. So that's about the promise, the use cases. Now let us talk about the future trends. So according to Andrew Ng, you all must be knowing Andrew Ng. He's a renowned figure in artificial intelligence. So artificial intelligence is being used for high value applications like ad business, in terms of generation, prediction, and so on, or web search for that matter. But according to Andrew Ng, there is a long tail. There's a long tail comprising the applications with lesser value, like t-shirt product placement, demand forecasting, and pizzeria demand forecasting. So there's a long tail where AI is not being used today and where there is a potential for AI. So AI grew vertically, became very powerful. Now, according to Andrew Ng, it should grow horizontally to small businesses as well. But even before all this, even before the large language models came into existence or became popular, for the last approximately 7 years, I've been asking my students to work on this homework problem. So the homework problem is to browse through the United States Bureau of Labor Statistics occupational classification. And I asked the students to select 5 occupations from the list that have the most potential to be fully or partially automated using machine learning. Then I asked them to why they chose them and your ideas on how machine learning can help automate the occupation. So your next startup could actually fire up from this analysis. So that's what I tell my students to do, because I want to create entrepreneurs, at least motivate the creation of entrepreneurs. So there was a recent study by MIT, Massachusetts Institute of Technology, on why 95% of the Gen AI pilots fail. The main reason they attribute to is friction. So this table highlights that most Gen AI pilots fail not due to technology itself, but because companies avoid necessary friction. The friction is in the form of human, organizational, and technical. So the pilots that succeed embrace friction, focus on back office integration, and partner with specialized vendors. You can see that here. So back office is basically like the company supporting team. So they handle all the administrative tasks that don't involve direct customer interaction. So using AI for these kind of activities, according to this study, is a good idea. There are other interesting ideas like the concept of humble AI and things like that. So you can probably read up the study yourself to find more, but it's an interesting study. So one way to alleviate the friction is to involve human beings in the loop, right? In these workflows on the slide, the process often follows a pattern where AI initiates or automates routine tasks, then pauses for human review at critical or uncertain points. So humans then approve, reject, or modify AI outputs via integrated tools before AI can proceed. So this approach balances AI efficiency with human judgment to improve accuracy. And of course, it also helps with compliance, ethical standards, and trust particularly. So that trust will probably address some of the friction that is there. So there are many other workflows. I will not cover them now. But this paradox is pertinent in this context, right? So this Moravec's paradox states that it is comparatively easy to make computers exhibit adult level performance on intelligent tests or playing checkers, and difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. So this paradox explains why the uneven nature of artificial intelligence progress is currently manifested with. So that's one thing. And more importantly, it reminds us that replicating human abilities entirely may take much longer, if not impossible, than we expect, because the processes we take for granted are far more complex than they appear. So with that, I open up for any questions that I can answer. And please feel free to connect with me, even if we don't have time for Q&A, enough time for Q&A, you can always connect with me and we can chat online. So are there any questions?
Thank you very much, Dr. Vishnu. The floor is now open to us to ask questions. If you have any question, please kindly raise your digital hand. Okay.
So Samuel, please go ahead.
Thank you very much, Doctor. What a well-delivered presentation on AI or die. My question is, you talk about the fewer-shot learning, which is a supervised learning model, which require fewer data to be trained and make a useful prediction. My question is, in an event where data is missing features or not correctly labeled, can the model still be used?
So it can be used, but the accuracy will be very limited, right? If you give wrong inputs, the outputs cannot be expected to be correct, right? So if the labels are wrong, then the answer may not be all that accurate. But you raise a good point, right? So these large language models have been trained on the entire World Wide Web. And we know that a lot of the content on the World Wide Web is noise. It's inaccurate, it's incorrectly labeled, and a lot of misinformation and things like that. But if you look at the answers from ChatGPT or for that matter, any other large language models, they're reasonably accurate. So that means these models are able to make the signal out of the noise. The signal to noise ratio is pretty high for these models. So yeah, you're right in raising the question about the incorrect labels. So uh, so so the models are doing relatively better than we expect in terms of handling noisy labels. But again, we cannot uh, rely on that fact. So the chances that the labels, incorrect labels, will produce incorrect information are there. We cannot completely rule that out.
Thank you very much.
Yeah, sure.
Okay. Dr. Vidya.
Yeah, please unmute, Dr. Vidya.
Try to. Yeah, okay, right. Thank you, Doctor. Can you hear me?
Yes, yes.
Okay. Dr. Vishnu, it's a great presentation. And now I realize that if you don't comply, you die. So you better have your AI hat on. And I got two quick questions. At the beginning, you brought this line up. AI double its capacity in a matter of 4 months. How does that happen? Is it because of the data availability, or how is that? And then number two, medical imaging. AI does a marvelous job, and it predicts certain diseases which a human medical doctor will not be able to identify. So does that mean that all the radiologists are going out of business?
Yeah, very good questions. Thanks for the questions. So, so the first question. So why is this rapid pace? The reason is because of the interest in the field, right? So there's no single attribute, there's no single factor that can be attributed to this growth. So the growth is happening because of the advancements in hardware, software, algorithms, data, everywhere. Pretty much no aspect is going untouched because of the tremendous interest that that is there in this field. See, for instance, there are 86 participants on today in this session, all probably because of artificial intelligence, right? So that is what is contributing to the interest in the field is what is contributing to the rapid growth. The technologically, almost every aspect of the technology is growing, is increasingly growing at a very rapid pace. So all that is contributing. So in terms of algorithms, I don't know if I talked about context windows. Yeah, I think I talked about, right? Uh, so so yeah, the context window has grown from just a few years back, like 3 years back, where 3 to 4 years back. Yeah, 3 years back, when I had a lot of ideas about increasing the context window. Those days, the context window was like 2048 tokens. Now it is like million tokens, right? So 10 million tokens.
10 million, yeah.
From 2048 to 10 million. So all my research pretty much was thrown out of the window because of this. So that is the kind of pace we are experiencing.
Right.
So that hopefully answered the question. And about the
Medical imaging.
Yeah, medical imaging. So what was the question? Yeah, the radiologist, right? The
Yes.
radiologist will go out of job. So that is where this human in the loop comes into picture, right? The human in the loop is very important. So doctor reviews and approves AI-generated diagnosis. So in fact, you bring up an interesting point. A few years back or a few months back, the godfather of artificial intelligence, Jeffrey Hinton, said that radiologists will be probably the first profession which will go out of out of their jobs. So he made that claim, but it hasn't happened yet, and I don't think it will happen because we still need the human in the loop. We need doctors to approve AI-generated diagnosis before communicating to the patient.
Right.
So yes, it will tremendously help the productivity of the doctors, but the doctors are not going to be completely out of their job yet.
Yeah.
Yeah.
Thank you so much, Dr. Vishnu. Great presentation, and thank you so much.
Yeah, sure. Thanks.
Miriam, please.
Thank you so much, Dr. Vishnu, for that wonderful presentation. I've been eagerly waiting for today. Okay, so I have two questions. The first one is about the future outlook. So first of all, what skills or mindset do you think students today need to thrive in an AI or die world? Because that topic is really, really enticing. That's my first question. My second question is about ethics and human impact. How do we ensure that the urgency of AI adoption does not overshadow human values and rights? I remember you talking about digital twins that you created for yourself that allows you to see your medical history and stuff like that. And you talk about the fact that it is something personal. So how do we ensure that stuff like this does not overshadow human values and rights? Thank you so much.
Yeah, thanks for the good questions. So let's answer one question by one because my context window does not extend to beyond one question. So the first question is the skills that the student should practice. So one very important skill is math, right? So artificial intelligence is all about numbers and math. So to be able to control at the pace at which it is progressing, and to understand the pace and the technology that is rapidly progressing, you need a lot of aptitude towards math. So math is an important skill, and general curiosity. Right? Curiosity is the most important aspect for learning. So you need to remain curious, be surprised by, if you think what is a big deal? Okay, it is going at the rate of doubling every 7 months. So what's the big deal? Then that's not enough, right? The most important soft skill is curiosity, and the most important hard skill is math. So that is what I would think. And now coming to the ethics topic. Ethics is a very big area. In fact, a number of my, you introduced me as having given talks, many talks, which are on YouTube and IEEE TV. Some of those talks pertain to this ethics aspects of artificial intelligence. So it's a very broad topic. Uh, uh, but there are efforts to, of course, address those ethical issues. But of course, this is a race. I mean, the whole idea that I wanted to give this talk is that this is a race. So nobody wants to be left behind. So in the race, ethics can take a back seat. So in fact, they will take a back seat. That is almost guaranteed. So the government should step in, right? The government, the standards bodies, all this should step in and come up with regulations. So regulation is very important and standards are very important. So for instance, in IEEE, I was part of a standard which was recently concluded. So we covered a number of possibilities, corner cases, and many things to come up with these standards. So these standards are well thought out. So hopefully they will feed into the regulation aspects from the government, and hopefully things will be addressed pretty soon. But yeah, that's a very pertinent question. The pace at which the ethics related stuff is progressing is far from desired. Let me put it that way. I hope that answers the question.
Thank you very much, Dr. Vishnu. Before I allow the last hand that is up there to ask the question, Professor Celestin, I'm sure we have one or two comments to make before he finally invite the head of school to make a presentation. So, Timiano, kindly please, quickly, let's have your question.
Yeah, please unmute and ask the question. Timiano.
Timiano. Okay, maybe it's not around anymore.
Hello, can you hear me? I was finding it difficult to unmute myself, but I
Yes, we
just...
can hear you now. We can hear you now.
Okay, so thank you so much for the wonderful presentation, sir. So this is my question. In your report, in your talk, you gave a report of MIT, why 95% of the businesses who try to implement AI in their businesses failed. In view of that report, I would appreciate if you could share one example, like in one case study of a business in the category of the 5% that were successful, what they did that was significant for them to make them to be successful, and one example of the 95% that failed and what they did that made them fail. Thank you, sir.
Yeah, thank you for that question. So the success strategy they identified is to develop learning loops, context retention, humble Gen AI, partnerships, workflow integration. So some of the success strategies are basically to use vendors. So the startups which used vendors were successful 67% of the time compared to companies or startups incorporating their own AI tools. So the success rate was only 33%. So one big feature is the vendors, using the vendors. So that probably is intuitive because when the transition comes through vendors, outside vendors, there's less friction, right? We kind of take it for, we kind of accept it. If it is internal, then there is a tendency, oh, these guys are internal to us, so why not we raise concerns? So the friction will be far less if it is vendor driven. So that is one success idea. And the other success idea they mentioned is back office focus, right? So many companies are using AI just for their the bread and butter, but the support functions also should be automated. So when the support functions are automated, the word spreads, right? Pretty much spreads, and the productivity gains are enjoyed by everyone, and there's less friction. So these are some of the strategies for successful AIs, AI startups. In terms of the failed startups, the main reason is employee friction. That's what they claim. So yeah, the main the friction can exist in terms of human friction, organizational friction, and technical friction also. Like technical friction deals with tools that don't retain context, that can't learn from the feedback, and lack of domain specificity. So these were the friction. These were part of the friction that came from technological implementation. So the idea, like we talked in the context of healthcare also, right? Domain specificity is very important. Like the models that were used for the eye images were trained on retinal images, right? So domain specificity is probably one of the lacking features in the companies that failed, right? So yeah, more details. This is available online. I got this article online on Forbes website, so you can probably look at it for more details. I hope that answered the question.
All right. Thank you very much, Dr. Vishnu, for that brilliant presentation and the question and answer time. For the sake of our audience, please, you feel free to connect Dr. Vishnu on LinkedIn if you need more information. In fact, he has brilliant videos there about talks and lectures. You can just feel free to connect with him on LinkedIn, and then you get more. So I'd like to invite the initiator of this November to Remember, Professor Celestine Wendy, to make one or two comments before inviting the head of school. Professor.
All right. Okay, I was already talking without knowing that I was muted. Yeah, thank you so much, Dr. Vishnu. I don't have much to say because we have exceeded our time a little, but we appreciate, I think this is the 4th year now, you've responded every time we call, and you always bring something new. You know, that is a hallmark of a very good researcher. And I know you are going places. Thank you so much for what you do for IEEE. And thank you again. I know the next time we'll try to bring you in person. Ladies and gentlemen, I welcome the head of school, Sam Johnson now. Thank you.
Thank you, Professor Celestine. Welcome once again, Dr. Vishnu. I've seen you for several years now and enjoyed your talks. I'm sure everybody on the call would want to say a huge thank you for such an informative and insightful session. I think certainly you've generated a lot of curiosity in myself and amongst all of the students, participants, guests, academics that are on the call today. I think also what was fascinating was the way in which you captured that race, you know, that emphasis on the race from AI to AGI to ASI, and goodness knows where we will go beyond that. It was a really fascinating talk. So thank you so much again, Dr. Vishnu, for joining us, for sharing your expertise. I know that people on the call will have many more questions, and I'm sure you'll be inundated via LinkedIn with people wanting to pick your brains and find out more about this important topic. But that talk was an absolute treasure chest of ideas and information. So thank you so very, very much for that. I'll just share my screen, if I may, and award you for the 4th year in a row. I think you must be winning in terms of the contest of our E awards. Thank you very much, Dr. Vishnu. Please accept this as a sign of our gratitude for sharing your expertise and specialist knowledge with us once again. And I do hope you can join us in person in the very near future. So a big thank you, everybody, for Dr. Vishnu for another fantastic evening. Thank you very, very much, sir. Thank you.
Thank you so much, Professor Johnson and Professor Celestine. It was great interacting with you all. Thank you.
So, all right. Thank you, everyone. That's it for today's program. We quite appreciate all of us for taking the time to attend this program tonight. We appreciate your presence, our head of school, Sam Johnson, Professor Celestine Wendy. Thank you very much. All our students, distinguished professors. Thank you, everyone. Bye-bye for now. Don't forget, tomorrow is another day, 6 p.m. for the next session. Thank you, everyone. Bye-bye for now.